Good morning, this is Dr. Turner for Integrated Math 3. Today we are covering 9.2, which is looking at the unit circle. Unit circle is going to be a big part of those, for those of you that are going on to calculus with me next year. Because we're on the integrated math track, typically we don't have what is known as pre-calculus or trigonometry in between. So we try to kind of cram that in at the beginning of the year as much as we can in the first month. The unit circle is going to be the start of that. Some of it we've kind of seen before, but let's go ahead and get started here. So with the unit circle, the idea is predicated on a circle that has a radius of 1. Now we have different ways of solving for missing sides, and we talked about in previous sections special right triangles, specifically 30, 60, 90 triangles, to where if I was looking at a circle that had a radius of 1, if it will load for me here. Okay. If I know that the radius is 1 and I was looking at specific triangles, I could solve for a point on the circle at any given point. Because let's say I took, again, we're looking at a radius of 1 here. So if I were to draw a right triangle, let's say that had a angle of 30 degrees. Well, that's a special right triangle. That's a 30, 60, 90. And so based on that, I could figure out what the length of either this side is or this side using the relationship where if I know the short side, the hypotenuse is twice that length. And if I know the short side, then the long side is that side times radical 3. So knowing the hypotenuse, for instance, in this case, the short side would be half of that, so 1/2. And the long side would be square root of 3 times that short side, which would give me a point on the circle at radical 3 over 2, comma, 1/2. And that's for a 30, 60, 90 triangle. Well, I could do the same thing for a number of triangles. I could do that for a 45, 45, 90 triangle. I could do that for a 60, 30, 90 triangle and be able to come up with the same types of measurements by looking at the special right triangles, either a 45, 45, 90 or a 30, 60, 90 on the circle. Again, all predicated on the idea that the radius is 1. Now by doing that, by going around, we end up with special values on what we refer to now as the unit circle. The unit circle is constructed like so, with those right triangles along a coordinate plane, x and y, with a radius of 1. And so we end up with these special points. Square root of 3 over 2, comma 1/2, square root of 2 over 2, comma square root of 2 over 2, 1/2, comma square root of 3 over 2. And these values will repeat because they're essentially the same triangles, just oriented differently in quadrants 1, 2, 3, and 4. The only thing that changes between those values are the signs. Now, we're used to looking at angles in terms of degrees. In units 6 and 7, we talked about how to convert between degrees and radians. Radians, just like temperature has different ways to measure it. We have Fahrenheit, Celsius, Kelvin. Another way of measuring angles is based on this idea of a unit circle, where we're looking at the distance around a circle. Now, we know that the circumference of a circle is 2 pi r, or pi times diameter. So if I have the unit circle where we've defined the radius as being 1, and I were to find the circumference going all the way around the circle, that would be 2 pi times 1, or just 2 pi. So rather than arbitrarily assigning 260 degrees, radians is saying, well, using a unit circle all the way around a circle instead of 360 degrees, that's going to be 2 pi. Now, based on that premise, 360 degrees being 2 pi, we can simplify that algebraically to define 180 degrees being equal to pi. Based on that, and again, if you need to go back at unit 6 and 7 and look at this, but based on this, if I want to convert from degrees to radians, I would do that by multiplying whatever the degree measurement is by pi divided by 180. And if I wanted to convert from radians to degrees, then I would multiply by the reciprocal, which is going to be 180 degrees over pi. Now, in the unit 6 and 7 assignments, I had you do that for a number of angles. However, here, what I want you guys to be able to do is to just look at the unit circle, familiarize yourself with it, and be able to identify the values that are on this unit circle. So, for instance, if I asked you, what is 30 degrees in radians, and this is in your supplemental resources, if you look at the unit circle, 30 degrees is pi over 6. If I asked you for 180 degrees, that's pi. If I asked you for 225 degrees, that's 5 pi over 4. And vice versa. If I give you the radians, you should be able to tell me the angle measurement. 3 pi over 4 is 135 degrees. 11 pi over 6 is 330 degrees. 2 pi is 360 degrees, etc. One of the first things you'll do if you're going on to calculus next year is you'll be given a blank unit circle after we study it for a time, and you'll be asked to fill in all the values that are shown here, because we will use these values in calculus time and time again. But that's it for today, guys. If you have any questions, please reach out during office hours. Otherwise, have a good day, and I will talk to you soon. Bye.